Hey there, welcome to The Explainer. Today we're going to get into the wild world of light, and specifically two of its most basic behaviors. We're talking about how light bounces, how it bends, and how those two simple things are responsible for everything from your reflection in a mirror all the way to how the internet works. So let's just jump right in. You've seen this happen, right? You stick a pencil or a straw in a glass of water, and it looks broken. It seems like it's bent right where it hits the water. But then you pull it out, and of course, it's totally fine. So what is happening here? Is this some kind of magic trick? Well, no. It's not magic, it's physics. This cool little illusion, and honestly a ton of other things we see every day, are all caused by two fundamental ways light interacts with stuff. And once you get them, you're going to start seeing them absolutely everywhere. Okay, so meet the two main players in our story today, reflection and refraction. Reflection is the easy one. It's just light bouncing off a surface, like a mirror. Refraction, though, is a little weirder. That's when light actually bends because it's passing through something, like from the air into water. So just remember that. Bouncing versus bending, that's the whole game. So first up, let's tackle reflection. This is the one you're probably most familiar with. It's the reason you can see yourself in the mirror, it's why you can see the moon at night, and it's why shiny things are, well, shiny. So the official definition says, reflection is when a ray of light hits a smooth surface and bounces back into the same medium it came from. The key phrase there is bouncing back. The light doesn't go through the surface, it hits a wall, basically, and just turns around. And you know what's great about reflection? It follows one super simple, super predictable rule. The light that comes in, we call that the incident ray, bounces off as the reflected ray. And the law is just this. The angle it comes in at is the exact same angle it leaves at. That's it. It's a perfect, neat, symmetrical bounce every single time. So really, the big takeaway for reflection is just how straightforward it is. Light hits something, it bounces off. Simple, clean, predictable. But that doesn't explain our bent pencil, does it? For that, we need something a little bit stranger. All right, now let's get to refraction. This is the big secret behind our bent pencil illusion. This is where light stops just bouncing off of things and starts traveling through them. And that, my friends, is where things get really interesting. So what is it? Refraction is simply the bending of light when it moves from one transparent material, or medium, into another one. So think about light traveling from the air, then through the glass of a cup, and then into the water. Every time it crosses one of those boundaries, its path changes, it bends. Okay, but why? I mean, why would light just decide to change direction all of a sudden? It's not just doing it for fun, there's a really solid reason behind it. And the answer is actually really simple. Light changes speed. You know how if you're running on pavement and then you hit a patch of sand, you slow down? Light does the exact same thing. It travels at different speeds through different materials. And that change in speed is what forces it to bend. And check out just how much the speed can change. In a vacuum, light is just booking it. But in water, it slows down by about a quarter. In glass, it's even slower. And then you get to diamond. Wow. Light slows down to less than half its maximum speed. The denser the material, the slower the light has to travel. So this gives us a simple rule of thumb. When light enters a denser material, it slows down and bends. But to finally solve our pencil mystery, we have to look at the opposite. The light that's bouncing off the part of the pencil that's underwater is traveling from dense water into thinner air. As it crosses that boundary, it speeds up, and that makes it bend away from the normal right before it hits your eye. That bend is the whole illusion. It's tricking your brain into thinking the pencil is somewhere it's not. Now, this whole light bending thing isn't just a neat party trick. It's actually one of the most useful properties of light. And we humans have figured out how to use it to create some absolutely incredible technology. I mean, seriously, think about it. Every time you put on glasses or pop in contact lenses, you are using refraction. Those lenses are just very precisely shaped pieces of plastic designed to bend light in just the right way to help you see clearly. Same goes for camera lenses, magnifying glasses, microscopes, telescopes. All of them are basically masterpieces of controlled light bending. Now, sometimes, if you get the conditions just right, refraction can lead to something really special called total internal reflection, or TIR. This happens when light is trying to go from a dense material to a less dense one, but it hits the boundary at a really steep angle. instead of escaping and bending all of the light that's trapped and reflects back inside. And where do we see this amazing light-trapping effect in its most beautiful form? You guessed it, diamonds. A diamond has what's called a high refractive index, 2.42 to be exact. That's just a fancy way of saying that it is incredibly good at grabbing light, slowing it down, and bending it. Way better than water or glass. So because of this powerful light-bending ability, diamonds are cut with very specific angles. The whole point is to trap the light that comes in. It hits the inside walls at that perfect angle for total internal reflection, so it bounces around inside the stone over and over again before it finally escapes, creating that brilliant, fiery sparkle we all know. But total internal reflection isn't just about pretty, sparkly things. The exact same principle is what makes our modern, high-speed internet possible. You see, fiber optic cables are really just incredibly thin, super pure strands of glass. A little pulse of light carrying your data gets shot into one end. It hits the inner wall of that glass strand at a steep angle, and bam, total internal reflection. It perfectly bounces its way down the cable for miles and miles, carrying our emails and videos at the speed of light with almost zero data loss. It's amazing. So let's bring this all home. We started with a simple question about a bent pencil, and somehow we ended up talking about diamonds and the internet. If you remember just one thing from all this, make it this. Reflection is a bounce. Light hits one surface and bounces off. Refraction is a bend. Light passes through a surface, changes speed, and changes direction. It's a simple difference that explains so much of our world. Which kind of leaves you with a final big question, doesn't it? From that bent pencil in a glass of water to the sparkle of a diamond, light is constantly bending and bouncing and twisting before it ever gets to our eyes. So it makes you wonder, how much of what we think of as reality is actually just a beautiful, complex distortion created by the physics of light? Something to think about. Thanks for watching.